Chapter 2 is going to bring us into the study of functions. It's going to talk about all of the different types of functions, all of the different properties of functions, and just in general, things about functions that you may have seen before, you may not have seen before. But it starts off in 2.1 with talking about domain of function, okay? And I'm not going to read through all of this, but the little story at the beginning is kind of entertaining, so take a second, read through it if you'd like to. But let's briefly touch on some of the definitions of functions, domain and range and things like that, things that you should already know. So a function, if you remember, is a relation between two variables, usually x and y, where you've got an independent variable, which in our situation is normally x, in the domain, and it goes to no more than one dependent variable, and the dependent variable is usually y, and we talk about that in terms of range, okay? So what this says is each x value has only one y value. So if you plug in an x value of, say, 2, you're only going to get one answer. You're going to get, like, if you plug in 2, you get 7. If you plug in 2, you might get 15, but you're not going to get both of those at the same time, okay? So you wouldn't get that if you plug in 2, you get 15 and 8. You're going to only get one answer, okay? And something that's important, especially in the study of calculus next year, is that there's different ways that you can talk about a function. You can talk about a function numerically, which is in terms of like a table. You can talk about a function graphically, in terms of a graph. And then analytically, algebraically, they usually call it analytically, in terms of some sort of function, okay? So sometimes you'll be asked to solve things numerically, or graphically, or analytically, and you need to know what the three mean, okay? I think graphically is probably pretty easy. Numerically, just remember, refers to tables and plugging in numbers. Analytically means you're going to solve for something, okay? You're going to analyze what it is, all right? If you're looking down here, they're talking about the analytic representation. The function is f, the variable is x, so this is just function notation. The next thing that's very important is something called the vertical line test. This should be something that you have already seen before and you're familiar with. Remember that a function is only considered to be a function if it passes the vertical line test. If you look back up at this graph up here, I'm going to use my pen as my vertical line. As the pen passes over the function, if something is a function, it will only pass through the pen once. So it's hitting the pen once. If for some reason your parabola had been sideways, you'll notice as I do my vertical line test, it'll hit the parabola here and here. So since it hits the parabola in two places, the sideways parabola would not be a function. So hopefully that makes sense. We'll look at some other graphs here in a second. On the second page, the first example talks about different relations as functions. So remember, the domain value is always the x, the range value is always the y. So each x goes to one y. So take a look at this first relationship. This x, -3, goes to 3, it goes to one thing. This -2 goes to -6, it goes to one thing. -1 goes to 0, it goes to one thing. 0 goes to 15, it goes to one thing. 1 goes to -1, it goes to one thing. So this is a function. Yes. Hooray, we got it. Look at this one. -3, one thing. 2, one thing. All of these pieces, all of these x values only go to one y value. Yeah, the y value they go to is all the same, but each one only goes to one thing. So yes, this is a function as well. Look at this one. One thing, one thing, one thing, one thing, but look at the 1. If you plug in the 1, you get 0 and you get 15. So this is a problem. So this is not a function. 1 goes to 0 and 15. Okay, so this is not a function. It's got two y values for one x value. This guy right here, 1, 1, 1, 1, 1. I'm not really sure where this 16 came from or what happened down here. So I'm going to scratch it out and we're going to just go with this guy. So this thing is a function. Okay. If the 1 had also gone to the 3 or the 1 had also gone to the -1, that's not going to work. Okay. Take a look at E. All of the x values I'm going to underline. If any of those x values go to two different things, like in the case of our 6's right here, this is not a function. Not a function. 6 goes to 1, and negative 5. So this is not a function. Again, 5, 5. The x value repeats and goes to 2 different places. Not a function. You'll also notice on this one that the 2 and the 4 both go to negative 1. I don't really care about that. All I care about is that these two x values went to the same thing. It doesn't matter that the x values are going to the same y values. It only matters that you have two x values going to different places. Okay, so hopefully that makes sense. Should be something you've seen before. So that's in set notation. So all of those were numbers going to places. It had arrows, it had coordinates. But looking at a graph, remember we talked about the vertical line test just a second ago. So I'm going to do the same thing. This parabola, if I do my vertical line test, it hits one time the entire time. So this, yes. This one is a function. Vertically, it will only hit one x value. Here's my sideways parabola example again. If I go sideways, I have hit the parabola in two places at the same time. So if I draw those in, do you see that those points are vertically on top of each other? So no, and it says explain why not, and I'm going to put does not pass the vertical line test. And I'm going to abbreviate that because I don't feel like writing all those things out. Vertical line test. Okay, vertical line test. Look at this one. Again, if I reuse my pen, all of the x values have one y value. So yes, this one is a function. Okay, this last set of graphs down here, again, there's no x's and y values here, so there's no place for my pen to pass twice. So we're good over here. Once the function starts, it only hits the pen in one place. I know it starts to get really steep right here, but that's still fine. So yes, as long as it's not completely vertical, you're okay. So yes, we're good. Looking at E. Still good, still good, still good. Yes, passes the vertical line test. Everything's fine. Take a look at F. As I run my pen over the function, you'll notice that when I get to the axis, I actually hit the function in two places at the same time. But look at those dots. I filled this one in a little bit darker because you could barely see it, but this one was filled in and this one is open. So this open circle just tells you where the function starts. So these two pieces right here, because this one is filled in and this one is not, that's fine. So yes, this is a function. If they were both filled in, then you would have 2 points in the same place and it would not be a function. So check for that, but as long as you have an open and a closed, then you're fine. Okay, and then the last part about finding if they have if they're functions or not is finding if functions off of equations. So we did it numerically with the points that they gave us, then we did it graphically with the vertical line test, and now we're going to look at the functions themselves. Okay, well, think about things with the function themselves. If you can solve for y exclusively and only get one answer, then you have a function. Okay, but if you could plug in an x value and get two answers, usually this only happens with square roots, then you won't have a function. So let's take a look at example A. If I were to solve that for y, so y squared would equal 6 minus 3x, then look what would happen. If I take the square root, remember we talked earlier that square roots give me positive and negatives, right, when I take a square root? So do you see that this will give me two answers? I'll have the positive version of the square root, and I'll have the negative version of the square root. So this is not a function. Okay, and they set it up here a little bit better. Look for even powers of y. If you have an even power or a mixed power of y, right, so where y's are squared, y's might be to some weird power, then you're not going to have a function. So just look for that. Looking at B, if I have 2x squared y plus 4 minus 8y equals 7x, let's see if I can solve this for y. So I'm going to subtract the 4 over. So subtracting the 4 over, that leaves me with this. Both of these terms have a y, so I'm going to factor that out. Leaves me with this. So I've got y times this because they both have that y, so I factored it out. Then I can divide by that, So I have 7x minus 4 divided by the 2x squared minus 8 term. So now do you see that the y is fine? For every x value, I'll get one y value out, not this plus or minus that happened on this one. So we're fine. So yes, this is a function. Okay, so this one's going to be fine. It's a function. All right. Also notice that your y's have an odd power. They're both the first power. So that should tell you right away that it's going to be a function. Looking at C, these have weird powers of y. So I have a y, I have a y, I have a y to the 3/2. Okay, that y to the 3/2 and the fact that there are different powers of y, so different powers of y, tells me that this is not a function without even having to do any algebra. So look for things like that. Notice these y's were both the same, these y's are different, so this one is not a function. So look for that, okay? This guy right here, x equals the square root of y. Well, to get the y by itself, I would just square both sides. So when I square this, I get y. When I square that, I get x squared. Y equals x squared. I have one power of y, so yes, this is a function. I guess I could have just written yes, but yes, this is a function. So look for different powers of y or even powers of y to determine if it's not a function analytically.